Okay, this is part 2 to the day 2. So I'm just going to write that up here. Part 2 of day 2. And these are problems number 7 through 9. 7, 8, and 9. So what we did earlier is we did problem 4, problem 5. We crossed out the original problem 6 with it was a badly written problem. So we did it alternative number 6. Please watch the first video if you want to review those. And this is problem 7. Determine if the statements in the table below are true or false about the sequences of transformations that can verify that the rectangle ABCD is congruent to rectangle A prime, B prime, C prime. Let me rewrite these letters so you can see them a little bit bigger. A, problem 7A. This is B here. This is C, and that's D. Now let's look where A prime is here. B prime is here. C prime is down here, and D prime is here. Now let's look, see how A is here and D is here. It appears that A and D have to reverse positions. So it looks to me like a reflection has to occur to get it over here. A reflection going this direction, A would still be on the, you would have an issue here. You could probably perform a rotation of 180 degrees to reverse all of these, and then it would be almost in the same position. But look, this is at 1, and this is at -1. Okay, so let's take a look. You could rectangle ABCD is rotated 80 degrees counterclockwise. Okay, well, this is clockwise. And then counterclockwise is that direction. We're just going to put CC. So it's rotated counterclockwise about the origin, which would put it down over here and be down here. C would be all the way over here, and D would come and it would be over here. So about the origin, followed by a translation of 5 units up. Well, we rotated it here, but we then moved everything up 5 units. You could imagine that it would end up somewhere in this area over here, and that is not going to map properly. So that is not going to work. So you really have to try and look at what they're describing. Now we have a second one. Rectangle ABC is reflected across the y-axis. Okay, we talked about this first. If I reflect it across the y-axis, then if C is here, this would be the C, we'll just call it C image. This would become B image. D would be over here. I should call it R for reflection. Let me erase it all. Change it to reflection, reflection, reflection. And then A reflection would be here. That looks good. And it's over the y-axis. And then it says, I'm going to move it. That's the reflected across the y-axis. Then I'm going to move everything 1 unit down by translating it. Well, that's good because I want to get, this is at 2. I want to get everything, all these are going to move down 1 unit. That looks good. So I'm going to move this down and that down and this one down and this one down. So then it's going to look, I'll do it in blue. It would be here. That looks good. And then it says followed by a reflection across the x-axis. That's going to really work out really great because if I then reflect it again, then this is going to go down You can see it's one away, so its reflection is one away. This is one away, so its reflection is one away. This guy is way up here, so it's going to reflect. It's going to hit perfect. And then this guy, right here, the C would be here. If I move it down here, it's going to work out just great. So that'll work. So I'm going to erase this. And that will work. So let's take a check on that. True. Okay, the third one. Rectangle ABCD is translated 5 units up, followed by a reflection across the x-axis. Rectangle ABCD is okay, so we're talking about this rectangle. You're going to move it up 5 units. Uh-oh, that's pretty far away. And then reflect it across this x-axis. Well, all you're doing is moving it up to here, and then you're going to reflect it. It's just going to end up down here if you're going over the x-axis. So that's definitely not going to work.
Good morning, PG teachers. This is a reminder. If you have morning yard duty, please report to your area at this time. Once again, if you have morning yard duty, please report to your area at this time. Thank you.
Problem 8. The triangle shown on the grid below has vertices at A, 2, 3. Okay, so this is actually has a problem here. We know that, let's call this A here, 2, 3. Let's change this to, this is A, and that's B because they have a typo. So change that on your paper. 2, 3, B is at 2, 5, and C is at 4, 2. Moving along, suppose the triangle is of an image here is a triangle that results from reflecting about the y-axis. Here's y. So it's 2 that way. We need to move it 2 here. That's B prime. And then let's move them all. That's 2 that way. We need to move. This one is here. A prime is here. We got that. And then this is 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. It's here. So let's connect these. We got this, this, and this. And then we're going to go ahead, and this is C prime. We're going to move it, translate it 2 units to the right and 3 down. So I'll take a different color. I'm going to make it 2 to the right and 3 down. I'm going to go 2 to the right, 2 right, and 3 down is here. We're going to call that B prime prime. 2 right and 3 down gets me to the origin. That's A prime prime. And then 1, 2, 1, 2, 3 is here. C prime prime. So I'm going to connect it here. And if I want to write the location, A double prime is at 0, 0. Again, remember we switched A and B at the beginning. B double prime will be at 0, 2. And C double prime will be at -2, -1. And let's look at the last problem. Problem number 9. Parallel lines. L and M. Well, when you have parallel, make sure you mark that as parallel with the 2 little red marks. Okay. And then we're going to look. It's cut by a transversal here and another transversal. So we need to look finally at if we have a parallel line and another parallel line, and this angle, this line's not changing. So this angle here is going to match with this angle. But on the obtuse angles, I like to use the big one. So this inside angle, I'm going to use a single here and a double here. I like to use doubles with the obtuse. So the same thing here. This line's straight, and these are parallel. So the angle formed here, I'll use 3, is the same as the angle formed right here, this other acute angle. So this angle here, the 4 one, is 4. So if this angle and that angle are the same, and this angle are the same, so the 3 angles have to add up to 180. Well, this and this are the same angle, and these 2 are the same.
Ms. Moreno, and Ms. Samron, please report to your yard duty area at this time. Mr. Fever, Ms. Moreno, and Ms. Samron, please report to your yard duty area at this time. Thank you.
So we have this third angle of the triangle has to be the same because these two are the same, these two are the same. This third angle have to add up to 180. So let's call them angle 1, angle 2, and 3. And we'll call, so we labeled the single one 1, the purple one 2, and this one 3. If we can find them in the same order, then we have similar triangles since they have 3 angles that are the same. Let's look at ABC. A, B, C. Looks like I labeled that angle 2, angle 1, and angle 3. Okay, 2 to 1 to 3. Let's try this one. E, D, C. E was 3. D is 1. And C is 2. That doesn't match. Let's try CAB. CAB. 3, 2, 1. Let's do 3, 2, 1, and then CDE. CDE. 2, 1, 3. Not working. Let's try one other one. BAC. 1, 2, 3. And then EDC. EDC. 3, 1, 2. Let's try the last one. BCA, 1, 3, 2. ECD, 3, 2, 1. Okay. Well, if we're looking for the triangles in exactly the same order, then we have not found one that lines up exactly. We will return to this problem in class, and I will cover it in class.